In this ACT video, we're going to take a look at trigonometric ratios. And you can see on the screen here, I've got a right triangle because we use trig ratios to compare sides of right triangles. And we'll use these ratios later in some more ACT videos to help us find missing angles and missing sides. When we can't use the Pythagorean theorem. So before we get there, though, we need to discuss the trig ratios. There's actually 6 of them. I'm only going to discuss 3 of them with you right now: sine, cosine, and tangent. And they have some abbreviations. And down here in our right triangle, before we get started on the definitions of these trig ratios, we need to pick an angle that's not the right angle. And I'm just going to pick this lower right hand acute angle. We're going to label that theta. Okay, I could have chosen this one up here, but I just chose to use this bottom one. And so remember, it always needs to be the acute angle, either one of the acute. We don't use the right angle. Now, labeling this right triangle, what we've done before is labeled the hypotenuse, which is always across from the right angle. And then the other 2 sides are the legs. But let's be more specific, and with respect to this angle that we labeled theta, which just means, when I say with respect to an angle, that just means we're looking at this particular angle. The side across from it, we're going to label that now as the opposite side. It's still a leg, but it's opposite of that angle. And this other leg, because it's next to the angle, we're going to call this the adjacent side. So opposite, adjacent, and hypotenuse are the words we're going to use when we define these trig ratios. Now, the trig ratios are as follows: sine of theta. We abbreviate sine, and then this is always your angle piece. In this case, we're using theta. It's defined as the opposite over the hypotenuse. Cosine theta, cosine of theta, abbreviated COS, is the adjacent side compared to the hypotenuse. Adjacent over hypotenuse. It's a ratio, so it's a comparison of 2 sides. And tangent theta is equal to the opposite side over the adjacent side. Now, sometimes people use this little phrase, SOHCAHTOA, to help you remember the definitions. SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay. So let's take a look at an example and how we might use this, or we might see it on the ACT. Here I'm asking you to find the value of cosine theta plus sine theta using the triangle below. And this is just a good old 3, 4, 5 right triangle, a really common right triangle. Well, with respect to this angle theta, 5 is always the hypotenuse because it's across from the right angle. Hypotenuse doesn't change positions. Now the 3 and the 4, with respect to that angle theta, the 4 would be opposite of the angle, and the 3 is adjacent to the angle or next to it. Recall the definition for cosine is adjacent over hypotenuse. So the cosine of theta would be 3 over hypotenuse, 5. And recall your definition of sine theta is opposite over hypotenuse. So sine theta is opposite, would be 4 in this case, over the hypotenuse is 5. And then the question asked you to find the sum of them, cosine theta plus sine. So we just need to add 3/5 plus 4/5, and that gives us 7/5. So all we're doing here is practicing these ratios and knowing these definitions. Now, I mentioned there were actually 6 trig ratios, and all I've talked about here are 3. So the next three are actually going to be pretty easy to remember if you remember sine, cosine, and tangent. So first, we're going to look at cosecant. And cosecant is abbreviated CSC, cosecant of theta. And it's actually the reciprocal of sine. So sine is opposite over hypotenuse. This is hypotenuse over opposite. So if you know sine, then you technically know cosecant because you just have to flip the definition over. We also have secant, which is abbreviated SEC theta, and it's the reciprocal of cosine. So it's going to be hypotenuse over adjacent. And then we have cotangent. And you guessed it, it's the reciprocal of tangent. It's abbreviated COT, cotangent of theta, and that's going to be adjacent over opposite. So let's look at an example. And the question asks you, in the triangle below, what is cosecant theta equal to? So here's our triangle, right triangle. This leg is 3, this leg is 2. And here's our angle theta. So with respect to angle theta, so that means we're looking at that particular angle that's labeled. And the definition for cosecant is hypotenuse over the opposite side. Now, here's a curveball. We don't have the measure of the hypotenuse. We don't know what that is. So let's label it C, and this just turned into a two-part problem. You're going to have to first find the hypotenuse and then use your definition. So first, we're going with leg squared, 3 squared, plus leg squared, 2 squared, equals hypotenuse squared. Good old Pythagorean Theorem. 3 squared is 9, plus 2 squared is 4, is equal to c squared. 9 plus 4 is 13, is equal to c squared. Take the square root on each side. Squared and square root cancel, so c is equal to the square root of 13. So now we have our hypotenuse piece, so we can say that the cosecant of theta is equal to hypotenuse, square root of 13, over opposite, and the opposite of that angle is 2. So square root of 13 over 2 is our answer. And that's a good ACT type question because it had 2 parts in it. They're testing you on your trig knowledge, and you had to do the Pythagorean theorem. So make sure you study and know those definitions. If you know sine, cosine, tangent, then you know cosecant, secant, and cotangent because you just have to flip them over.